All right, so let's get back to water. What is said to be the water is said to be the universal solvent. What does that mean? Well, what it means is that water will form mixtures with ionic and polar molecules. Ionic we know, but polar, what is that? Well, polar is a type of covalent bonding. Covalent bonding? What is that? Okay. Let's use an analogy. And we're going to use Ben. Ben has a good sense of humor. Ben, you're this electron right here. Okay? That's you. You're a negative little particle. Just a negative little particle. Okay? You are bonded presently to this really ugly girl. Not Haley, it's another girl. Really ugly girl that on a scale of 1 to 10, she's a 1. Oh. Metals are ugly girls. Ugly, ugly, ugly. I mean, the prettiest metal is a 2 on a rating of 1 to 10. That's how ugly they are. Okay. Now, along comes Haley, and she's a 9, isn't she? Yeah. 9. Oh my gosh. So Haley scoffs and says, "Oh, you poor dear. You are bonded to that ugly girl. Why don't you come over here and be with me?" Here are your choices. You can say, "Oh no, I'm kind of loyal to this girl. No, I'm sorry, Haley." Or you can say, "Okay, how about if both of you share me?" Or you can say, "Forget this, ugly girl. I'm going with Haley."
Is this a test?
Haley's not here. What would you do? Come on. Come on.
I would go to Haley.
You would go to Haley. Good answer, since she can actually hear this. All right. That, my friends, is an ionic bond. In an ionic bond, you have a metal with Ben. But that metal is ugly. The non-metal is beautiful Haley. And she wants Ben. And Ben is transferred from the ugly girl to Haley. From the ugly girl to Haley. So what is covalent bonding? All right. Haley, hang in there. This is just a metaphor, okay? All right. Here we go. Ben. Now be realistic, Ben. Be realistic. Here's Haley. She's a 9. Okay. And here's another girl, and she's an 8. And they both want you. Here are your choices. Forget the 8, go with Haley. Or share them. Date both of them. Spend some nights with Haley, spend some nights with the 8.
Is Haley listening?
Haley's not listening, no. She doesn't listen to these things. Be a man about this. Be realistic. Yeah! That is covalent bonding. Covalent bonding occurs when electrons are shared. See, non-metals are good-looking girls. Okay? There's not one red-blooded American guy here that wouldn't go, "Okay, I'm not married to them. I'll let them share me." Right, Spencer? Yeah, yeah. Okay. So covalent is when an electron is willing to be shared by 2 non-metals. So what is a polar covalent? No. Get back to, let's make things a little more difficult. A 7. So she's not as pretty as Haley, but she's still, in the grand scheme of things, pretty. All right. Do you want to be shared equally? That means 3.5 days for Haley, 3.5 days for the number 7. Or do you want to be shared unequally? That means Haley's a good deal better looking. So I'll go 5 days with Haley, 2 days with the other girl who's not that bad looking either. Come on, be realistic.
Yeah, I'll go 5 and 2.
Yeah, 5 and 2. I'm glad. The first period, unrealistic. The guy would not admit that. Okay, thank you. So what we find is unequal sharing. Unequal sharing. And if you think of Ben being an electron, electrons are negative. So what we find is that since Ben is spending more time around Haley, then what happens is you get a negative side and a positive side. The side that Ben spends more time near is kind of negative, and the side that Ben spends less time is kind of positive. That's why it's called polar, because it creates positive, the side that Ben doesn't spend too much time with, and negative, the side that he does spend more time with. Sides. Remember, not all atoms are created equal, just like not all girls are equally, they're all beautiful. Not all of you guys are equally beautiful, right? Some girls are better looking than others. So electrons, being the dog that he is, electrons tend to stay closer to the better looking girls. Okay? So, because electrons are negative, that means that side of the molecule tends to be negative, while the other side tends to be more positive. That's why you have a negative side and you have a positive side. Ben, you're not off the hook. There's going to be one more possibility.
Sure, both of them the entire time.
Ben, you know Haley, unbelievably beautiful, right?
Yeah.
Yes or no?
Yes.
Yes, an emphatic yes. Haley is unbelievably beautiful.
Right.
What if Kate Upton comes to you and says, "Hey, I want you to be my boyfriend"?
Probably gonna date Kate.
Oh my gosh, you dog! Yes, very realistic. So, what would you do? Would you spend more time with Kate, who's a 9, just like Haley is? Or would you spend more time with Haley? Or would you say, girls, there's enough of me to go around. 3.5 days for Kate, 3.5 days for Haley.
Probably equally.
Ah, very realistic. There's a Brad Paisley song that says, I'm just a guy, right? Is that it?
Yeah.
Yeah, you got to read the lyrics, then you would understand. Yeah, just a guy. So what happens if both atoms are equally attractive? Haley and Kate Upton. They form a non-polar covalent bond. And this time, are you going to find Ben closer to one than the other? No. So it will not form positive and negative sides. It will not form positive and negative sides. Non-polar does not have positive and negative sides. Are you ready for the greatest video of the year?
Is it a Kate Upton video?
A what?
Kate Upton
Wow.
video? In slow motion?
What?
Oh. Oh my god.
Oh my god.
Ew. What? Oh, wait a minute. Oh.
Okay, so
An
imagine
ionic
the
bond
chew.
is
What
formed
were you guys
when
thinking
one
of?
of the atoms loses an
Imagine the
electron
chew
to the
toy.
other
Did you see
atom.
that? He's the
This
chew
results
toy.
in a positively charged ion
called a cation,
So the
and a
dog
negatively
that took
charged
the
ion,
electron
called an
away,
anion.
that dog is negative, and the other dog is
Positive and negative attract, and the result is an
He's the
ionic
chew
bond.
toy. Isn't this awesome?
Covalent chemical bonds
Okay.
involve the sharing of a pair of valence
Sharing!
electrons by two atoms. There is also what is called polar covalent
Now
bonds.
what happens if it's
These are
polar? What's
covalent
going to happen?
bonds in which the sharing of the electron pair is unequal. The result
Is it equal
is a bond
sharing?
where the electron pair is
So
displaced
he's
toward
more
the more
on the
electronegative
tan
atom.
dog side. So that side is more negative than the other side. What about if it's...
Thanks for watching, and we'll see you guys next time.
Best video of the year. Now, do you understand ionic, polar, and non-polar? So ionic is when one dog took it away from the other. Okay, non-polar is when they were sharing, right? And polar was when one dog was pulling the other dog across the room. Okay, so water is known as a polar molecule. What does that mean? That means the oxygen is the really pretty girl. The hydrogen side is the side that is still pretty, but not as pretty. Okay? So, Ben is the electrons that are shared in between, but most of the time Ben is going to be found near the oxygen side, making oxygen more negative. The oxygen side is more negative than the hydrogen side, creating poles. So, how do these properties affect water? Well, because water is like a little magnet, a positive and negative side, water will stick to itself. Surface tension. Surface tension. Water becomes like a little magnet. So how does all of this explain the concept of universal solvent? Well, water is not only polar, water is very polar. Actually, hydrogen is pretty, but she's not too pretty. Oxygen is gorgeous. So this water is actually very close to being an ionic bond. It's not, but it's close. So water is extremely polar. This allows water to dissolve ionic and polar covalent bond. The one thing that water cannot dissolve is nonpolar. Why? Because water is like a little magnet, and imagine nonpolar as being a piece of paper. What happens if you try to get a magnet on a piece of paper?
It doesn't work.
What happens if you get another magnet in there? Then the magnets will stick. So it's not, your biology teacher told you that oil and water, oil is hydrophobic. Water is not afraid of oil, okay? But oil does not have a positive and negative side. So it would rather stick to itself than to mess with oil. Okay? Water is not afraid of oil. Water just loves sticking to other things. And it'll stick to anything that's polar, but cannot stick to anything that's nonpolar, because nonpolar does not have sticky sides. So what is a good way of picturing dissolving like? If salt is dissolving, what does that mean? It's kind of like a tug of war. Will the sodium and chloride ions be more attracted to themselves, or will they be more attracted to water? Will the sodium and chloride ions be more attracted to themselves or more attracted to water? If they're more attracted to water, then the thing will dissolve. If they're not, then it will not. Let's see if salt will dissolve in water.
Sodium chloride crystals are held together by attractive forces between the positively charged sodium and negatively charged chloride.
Okay, so the transfer of electrons has already occurred. Sodium lost its electron, sodium lost Ben to chlorine. Chlorine's better looking. Okay, So now because sodium is positive and chlorine is negative, they will stick to each other. So the question is, when sodium meets water, will sodium rather be with water? When chlorine meets water, will chlorine rather be with water?
Ions. When a crystal of sodium chloride is placed into water, the hydrogen ends of polar water molecules.
Okay, so this is the hydrogen end. That's hydrogen, not as good looking. So most of the electrons are not around hydrogen, so that means hydrogen is positive. Notice that it's going to where the green chlorine is.
Molecules attract the negatively charged chloride ions and gradually surround them.
Yes.
Likewise, the oxygen ends of water molecules are attracted to and surround the positively charged sodium ions. The hydrated ions drift away into the solution, allowing new water molecules to surround newly exposed ions. Gradually, the entire crystal dissociates into solution.